All right, this is going to be the first of many videos. I'm going to post these on uh, an app and a site called Patron. It's a pay a creator funding site where you can donate either tips or you can donate monthly. So it's just a way to fund creations, pretty much. This is going to be my introduction video, and it's also my very first video I've ever made, so bear with me. The project is a senior project. It's with a team of guys, and the videos will actually most likely take place in our advisor's office, and you'll see, step by step of our thought processes in engineering. It's going to be the real life day-to-day of us struggling through this project. So what is the project? The project is a challenge that DARPA, and if you haven't heard of DARPA before, DARPA stands for Defense Advanced Research Project Agency. The U.S. funds DARPA $2.97 billion annually, and most of the projects are coding based, like computer science majors would take on a lot of these, or really like Lockheed Martin or Boeing, places like that will take on these challenges, and it's a cash prize. They like to award it to universities. But one of the challenges is called the Sprinter 2 Challenge, and it happens to fall right in the same timeline as when our project is due, which will be next May 2019. I got an early start on this project by taking a research class with the advisor of our project, Dr. Gotzi. So the Sprinter 2 Challenge is a DARPA challenge to develop software packages for automation of drones in swarms. Swarms are groups of drones. Sprinters are drones in the swarms that advance first, check and make sure it's safe, or do some reconnaissance, and then communicate back to the swarm to allow the entire group to advance forward. A portion of the Sprinter 2 Challenge, though, is the platform, swarm platforms, and the ability to get the swarms to the locations. One of the challenges is when looking at small drones, like let's just say like insect-sized drones, you can't fly a small drone long distances. The batteries inside those drones are very small, and in turn that doesn't really let you get to your destination when it's over a long distance. So a solution is to have like a home for these little drones somewhere close so that they can cycle through and do their job. The best way I know how to do this is just to draw as I talk. My communication, I feel like, is a lot better if I can draw as I make it. So let's just say you had your your base. This is all your guys, your drones, your equipment, everything is right here. Well, this will be a work in progress. So this being the first video, just hang with me. This is your home base, your home, whatever it may be. Here's your location. You need to see what is in this town of buildings, whatever it may be. This distance here is too long to fly my drones to, where they have enough time in here to do reconnaissance, fly around, map the buildings, the terrain, whatever it may be, whatever their job is. It's just too long. So essentially we need a vehicle of some sort to be parked right there and allow the drones to cycle in and out of the location. So for an example, let's just say we had 20 of these drones, little, let's just call them like bee or cricket sized drones. We have 20 inside of our vehicle when we drive up. We need 10 in the location of the reconnaissance at all times. So 10 will be in the vehicle, 10 will be in the town. You can set timers, or you can have drones communicate, or both, to allow for these 10 in the zone to constantly be at a charge to allow them to do their job. So say one of the drones gets to 50% battery. His job is, I'm at 50% battery, I need to return home, and I need to tell one of the 10 inside my vehicle to start coming into the zone so that we always have 10 in the zone. So as soon as its replacement shows up to the job, one of the bee-sized drones comes back, and this vehicle will allow it to charge and wait for its next turn to go in and do its job. So this vehicle right here, this is the project. This is a portion of the Sprinter 2 challenge that we are taking on. The actual terminology behind this is under section of the Sprinter 2 challenge called platforms. Provide novel applications of sensors, actuators, or effectors to enable new swarm autonomy capabilities. Integrate with architectures of swarm system integrators. This is a small portion that has no cash reward related to it. It's just too small. It's not the actual challenge. It is a portion of the challenge, but still cool. So our idea for this vehicle is we want to create a driving sphere. So it will be a spherically shaped vehicle and it will rotate, but some of the uses this thing needs to have. It needs to be able to charge these drones. It needs to be able to house these drones. It needs to be able to be stable and robust and do the mission. The mission being get to the location, park with stability, open with some hatch or system of deploying these drones and charge these drones while in the location. So some challenges that we're facing is the drive system for the sphere. The hatch to allow these drones to come in and out of the sphere. The swarm platform, I guess you would call it, the swarm plate. So where do these drones sit inside of this is a challenge. And there is quite a lot related to this that is the actual engineering challenge that goes along with designing and creating this. Another big challenge is the shell. What will be made out of? Will it actually be a full sphere? Will it be chunks? So these are some of the challenges that we are working on right now, and some of them have actually been solved a little bit. So we'll go over the drive system first. The drive system for this sphere, we found that a dual pendulum system is the best for this situation. The reason is with a pendulum system, you can have a plate that is located right on the full diameter of this sphere, and just underneath that plate will be a pinned system, and on that pinned system will be these two pendulums. And how does this pendulum system work? Here's a sphere, side view of the sphere. A motor will move my pendulum. Here's my pendulum when I am just at the sphere's north. When I move my pendulum to this position, the sphere wants to get to its center of gravity. So the sphere will rotate and bring the pendulum back to its original location. So I will get a rotation from the sphere while expending that much energy to move my pendulum. The sphere is always going to want to stay in the center. Its center of gravity is always going to be forward when driving forward, and it's always going to want to roll in that direction. A two pendulum system allows us to move one or the other, creating a turn situation. At this time, the system's already been proven. We've already built this with essentially Legos, and it resembles a soccer ball. And as these videos advance, you'll see us drive test this, you'll see failures, you'll see real-time engineering. So our drive system has been solved. It needs tweaks and tuning a little bit. We had a problem with some gears slipping, and we're going to have to do some energy analysis to make sure that this is actually a better solution than what you think would be the easiest way to drive a sphere, which is essentially put an RC car inside of the sphere and mount a pole with with a roller on it. And essentially you're just driving the sphere like an RC car. It's just like an extension to the wheels. One of the main problems with this is, how do I get a platform to house drones inside of the sphere when you have this type of setup? With this setup, the sphere has all of this space that never actually has any use other than a storage area. Like, this is all free space inside of this sphere to house the drones. And looking at this from a top view, you would just have, at least right now, the plate is a challenge that we haven't actually fully conquered yet. But as these videos do advance, like I said, this will be solved in real time. You're going to see us think this through. So I'm making this video because I am in the summer before my senior year, and Widener has us do senior projects. This is our senior project. I took an extra class that is a research class with the advisor of the project, and he's a good friend of mine. And we sit down and we talk about the project. I'm getting a head start on the project prior to the start of it. And Widener only funds a max of like $1,000, and we could just definitely use some more funds. That's, as the project goes further and further, we can do more and more and more if we had proper funding. We don't need $1 million, we don't need a ton of money, but little bits of money help, where we don't have to go to the scrapyard every single time and use used parts that are going to break or anything like that. If we had the proper motor after the design is complete and we found what we need, money is going to be an obstacle at some point. Right now, it is in the design phase, and I want to start this video early because this Patreon site, I just heard about it today from my neighbor Con next door. He said that it's a creators platform, so you create things and people essentially fund you for you. And the way that funds get to us is you can either like create, you basically give your credit card, and every month it'll get charged $5 or whatever it is that you decide to donate. And the other option is to do like a per video, or per I contribute and my contribution is compensated by your contribution. So you say like $5 per video or whatever it may be. It's pretty clear once and it's an app you can download through Google Play, or there's an Apple platform for it too. And I'm just gonna submit this and put it out there on Facebook and see what happens. And hopefully we can just get a little bit of money to allow this to go a little further. If anyone sees this video and they have a business or anything that they want a lot of like high profile engineers to see, this is our senior project, and we do have to present it in May of 2019, and we completely will accept any sponsorship that there is out there. If you have an idea, or if you have um, any branding that you want to put on this, it's um, all ideas we're open to. Like anything helps. So don't be afraid to contact me through Patreon, or if you want to email me, it's just my last name 102. It's AUXIER 102 at gmail.com. And I check it regularly. So if anyone has any ideas, any even ideas about the project, if you have any inputs, I'd love to hear them. And I'd like to make this a separate part to my education. I really think that this is going to be good for me, not just the team, but for me to advance as an engineer. Portion of engineering is finding money. So here's me doing it. I again appreciate any support, and I appreciate any help, any input, any feedback, any mentoring, anything. Thank you again for watching our video, and I hope to see you for the next one. Thank you.